Mr. Mack here. I thought I would do some practice solutions for this section for arcs and circles. And yeah, that's it, I guess. So I don't know if I'll do all of them, but we'll jump into a few here. So define arc in your own words. I would say an arc is part of a circle or a fraction of a circle circumference. Circumference. Endpoints would be on the circle. Let's identify a few things here. How about two semicircles? Okay, semi means half. So let's do, so if we do ED, for instance, this semicircle, it's kind of hard to tell if I say ED if I'm going on this side or this side of the circle. So how about I use 3 points here, and I could say EBD, and I'm going to put an arc symbol. So that's arc EBD. How about AFB would be another semicircle. AFB. Two major arcs. Okay, so a major arc is greater than 180. So I could say, how about AED, arc AED. How about arc EBF? All right, minor arc, less than 180. How about we do EB? How about this little one here, AF? Arc AF. All right, a pair of adjacent arcs. Adjacent means next to. So they're going to share the same endpoint and they're not going to overlap. So how about we do AE, arc AE, or EA, let's do EA, and AF. They both have the same endpoint A, and they're adjacent to each other. Okay, obtuse central angle. Well, how about this one? ECB. So for this is an angle. Here we labeled arcs. This one we're going to do angles, so I'm going to use the angle symbol. ACB, or ECB, and C is the vertex, so we write that as the center point here. That's the vertex. And acute, how about BCD? Angle, BCD. Use capital letters. Now we're going to find the angles here of this same figure. So we've got arc FD, FD, well that's 90. BDF, BDF. So this angle, actually, you know, it's kind of easier if we just go through and just find the angles around first. This has got to be 60. This is 90 and this is 60. This also needs to be 90, so I need a 30 here. Okay, so now I have everything. BDF is 90 plus 60 is 150. Okay, measure of arc AF is 30. EB, well, we already knew that. It's 120. AED is 180 plus 60 is 240. ABF, ABF, so we're going almost all the way around except for 30, so we're 30 short of 360, so that's 330. Okay, those are our solutions for that. Okay, fine. So we got more measures defined, the indicated arc. So this is arc DE. Couldn't find a really good symbol for arc. So these are all arc symbols here. So we got DE. DE, that's 90. Arc DC. Well, why don't we go ahead and solve these again. So that's 90 and this is 74. DG is a diameter. So this angle here, or this arc here, has to be 90 minus 74. That's 16. That's 82. These two angles and the 82 need to give us 180, right? So I've got two angles. So what if I take 180 and I subtract 82? And that gives me 98. So these two angles are both congruent. These are congruent symbols for our angles. They both add up to 98. So if I take half of 98, that gives me 49. No, it doesn't. Oh, yeah, it does. 49. 49 times 2 is, yeah, that's 98. So this is 49. So DC is 49 degrees. Arc GAB, GAB. I should really say for this one, angle GAB, because A is not on the circle. So this is really a better way of doing it. And let's fix that. Note to self, fix that for next semester. Angle GAB. All right, we already got that. We already know that one's 82. And then arc FG is 16 degrees. Okay. Find the unknown variable of each circle. Okay, so these are arc measures. 155 is the arc measure for AB, and then BCA is 4x minus 11, and we know that there's 360 degrees in a circle, so I can say 4x minus 11 plus 155 equals 360 degrees. Add like terms. So I'm going to take 11 away from 155, that's 144. Subtract 144 to both sides. Uh, 216. 216, that should work. Is I got 4x. Okay, whoops, dropped my pen. Okay, there we go. Divide by 4. And let's see, it's 216 divided by 4. 4 goes in 250, and 4 goes in 16. Okay, so this should be 54. Okay, that one's done. Let's see, how about we do, let's try this one here. So this angle here is, measure is y cubed plus 54, and this measure here is x squared minus 27x. I think I have x's and y's here, but I know this is 90 here, so actually this angle here is 270. Okay, so I'm going to write two equations here. How about we do the x first? I've got x squared minus 27x equals 90. Okay, we got a quadratic here. I'm going to subtract. I need to put this in standard form, so I'm going to bring the 90 over to the left by subtracting it. And now I have to factor it. And I want to find the factors of negative 90. Factors of negative 90 that are going to add to negative 27. So, I mean, we can go negative 9 and 10 are factors of negative 90, but when I add these, I get 1. So it doesn't work. If we play around with this enough, we'll see that 3 and 30 are numbers, but I need 30 to be negative. So when I add, so 3 times negative 30 is negative 90, but when I add them, that does give me the negative 27. So my binomial is going to be x plus 3 and x minus 30. And then now I want to see, well, what value of x gives me 0 in this quantity, because anything times 0 is 0. So it doesn't matter what's in this quantity here. 0 times that is going to be 0. So I can just set this quantity equal to 0 and solve, and it tells me the value of x. So negative 3 plus 3 does give me 0 here. I'm going to do the same here. Just take the x minus 30 and set it equal to 0 and solve, and I get 30. And I've solved for x there. So the x solutions are done. I'm going to go over here to the y, and I know that y cubed plus 54 equals 270. So I don't have any other y's here. I just have this one y, and I can just solve for y. I couldn't solve for x in the quadratic because x was in two different places with an exponent of 2 and an exponent of 1. So we had to factor this. This one, we're just going to solve for y and isolate it. Y cubed equals 216. Did I do that right? 16, 60, I think so. And then now I take the cube root of 216. And so 216, I'm going to make a factor tree here. 2 and 108, 2 and 54, 2 and 27, 2 and, not 2, 3 and 9, and 3 and 3. Okay, so when we did this before, we were finding, to simplify, square roots. Now we're doing cube roots. Actually, I got to put a cube here. We're taking the cubed root of 216. So instead of finding pairs, we're finding threes. So I have, here is a set of 3, so a 2 comes out. Here is a set of 3, and a 3 comes out. So there's nothing left. So this means that this is a perfect cube. So y equals 2 times 3, or 6. So 6 cubed would be 216. Okay. That one's done. And I'll do one more here. I'll do this one. We've got 11y is this arc measure, and we've got y squared minus 42 is this arc measure. And assuming that DE is a diameter and CB is a diameter, we know that these central angles are congruent because they're vertical angles, so therefore the arc measures are going to be the same. So we could say y squared minus 42 equals 11y. This is another quadratic situation. We want to put this in standard form. And now we got a factor. Factors of negative 42 that add to negative 11. So the factors that add to negative 11. So, negative 7 and 6 are factors. But that equals negative 1, so that doesn't work. Let's see, 6 is 2 and 3, isn't it? So let's see, what if I do, I put negative 14 and 3. Yeah, I stumbled right on it, right? So negative 14 times 3 is negative 42. But when I add these together, I get negative 11. That is my pair. I'll pop it in over here. And so if I set this equal to 0 and solve, I hope you guys see that we get y equals 14 and negative 3. Now, negative 3 is going to, if I put negative 3 in here, I'm going to get a negative arc measure, and that really doesn't make sense. So in this case, I think we're going to just use 14 for these right here, and can't throw that out. This clearly is not to scale. 11 times 14 is 154. So this is, if I actually make this problem to scale, this should be a much larger angle. This will be 154, and then 14 times 14 squared is 196, minus 42 is also going to give us 154. So it checks. The problem checks. It's not to scale, but that's the way it is. Okay, very good. I think that's all I'm going to do for now. Otherwise, the video is super long. If you have questions about the yellow ones, you know where to find me. All right, everybody. See you later.